I think good day everyone, and I think good night the one for people in Jakarta and Indonesia. Thank you for having me in this event to present about the bioenergy and also chemurgy research that we've done in Indonesia, especially in ITB right now. My name is Aksa, and I'm basically representing Department of Bioenergy and Chemurgy of Institut Teknologi Bandung, Indonesia. Okay, first I'd like to introduce first these two words, right? So I think the first word is pretty much self-explanatory. Bioenergy, we all know about the all renewable fuels, biofuels, biodiesel, biogas, and so on. And then we also have chemurgy here. So chemurgy here is basically a branch of applied chemistry where we basically try to produce something from a bio-based material. Right? So it's basically it's all about producing bio-based product. This is where we currently work right now. So this department is part of the new ITB campus. So we have a new ITB campus in Jatinangor. It's close to University Pajajaran. So this is, there are few a new department there, like bioenergy engineering and chemurgy, and also, for example, food technology. So we're basically part of the chemical engineering as well. So pretty much people who teach in chemical engineering, they also teach in bioenergy engineering and chemurgy. A little bit about the our department. So it's basically established about 2015 by Professor Tatang Hernas Surawijaya. So it's still pretty new. It's about 6 years. We're located in ITB Jatinangor campus. And then we currently have about 22 academic staff, mostly PhD. And we also have 4 supporting staff. In terms of student, we only receive about 40 students per year. So we currently have about 150 in the campus. And then we already graduate about 100 alumni. And then in terms of research outcomes in the last 5 years, we have about a quite big research grant. I think part of it comes from Pertamina as well. We have more than about 62 billion in Indonesian rupiah. So that's about what, 3 million pounds, I think. And then in terms of industry consultation, we also do a lot of consultation with industry. So it's about 12 billion Indonesian rupiah. And so far we managed to publish about 200 publications with over 10 intellectual property rights. So I think Mr. Tony and also Mr. Oki has present a few of the background why we need to move from this transition from fossil fuel to renewable fuel, right? So this is basically the current situation about biofuel in Indonesia. We're currently targeting about 31% in 2050 for electricity and transportation. And so far we managed to have about, I think, 12 million kiloliter in terms of biofuel. And then we're targeting about 14 million in 2025. I think we're on track on that one. And then we're going to triple it in 2050. So that's basically the situation about biofuel. But I think we can talk quite proud about our biodiesel program in Indonesia, because right now we have about 30% mix, which is actually the highest in the world, I think. Even Brazil right now, I think still below 10%, and they kind of learn from Indonesia the experience about how to move to a higher mix. And I think we're going to try to, actually this year, I think we try to move to 40%, but we still need to do some research and about how to increase, for example, the oxidation stability of biodiesel, and then we can move further into 100%. And then, of course, also we want to talk about the circular bio-based economy. This is one of the reasons why we built this new department in ITB, because we want to produce or create a technology and different kind of process where we can produce different product from bio-based material, right? So we can never separate between a transition to from fossil fuel to renewable without thinking about other products like chemicals, food additive, and so on, right? So, but of course, there is a challenges. I think the transition into the industry, it's not easy. How to bring the research into commercialization, it's pretty tough. We need a lot of funding, especially from a government sector, because most of the time industry only interested when we finish the pilot plan or go into a little bit commercial scale. And then of course lack of private investment also it's become more challenging right now. And then in terms of economic short-sightedness, the price of many products, of course, the conventional product is still cheaper compared to bio-based product. So it's not easy to convince everybody to jump into this bio-based product. And of course, in terms of public awareness, it's still also low. So we need to keep self-education about this bio-based product. But luckily, Indonesia is very blessed with natural resource, right? We're probably one of the country with the highest rate of photosynthesis. Therefore, we are quite rich in terms of lignocellulosic material and also the vegetable oil. The one that you see in here, a different kind of vegetable oil. I try to highlight what's the composition in terms of saturated, monounsaturated, because it's basically affecting the properties of the this vegetable oil when we convert it into a biofuel. So in terms of production, Indonesia is basically the #1 producer of palm oil. We are right now, I think, about 45 million ton just last year, and then 70% of it we basically exported, right? So a lot of money coming is from palm oil export activities. So we want to keep it that way, but we also need to be careful because it's when now there's so many palm oil producer in the world. I think it's starting with Malaysia also is one of the competition, and also Thailand. So this can basically become a threat in terms of the price, right? So we need to diversify the product from palm oil in order to keep the price in a good position, right? So and right now in terms of biodiesel mostly produced from palm oil. So we are now about 12 million kiloliter in 2020, and then we are going to continue to produce biodiesel and move also into biogasoline, biojet fuel, and so on. Okay, this is the chart of the potential of a fatty acid-based industry, right? So if you can see here, you can basically make or produce many products from fatty acid. It just right now it's a little still the price of fatty acid a little bit expensive because in order to produce fatty acid, we still need to use high temperature, like around 250 and 50 to 70 bar. So we need to improve also this process, and we are working on it. And so we're working with a few companies from palm oil refinery, how to improve the process in the fatty acid-based industry, right? And then I also want to highlight, I think Mr. Oki also shows already the potential of lignocellulosic material. So basically we can have a lot of product, but the challenge is how to separate this lignocellulosic material, because it consists of cellulose, hemicellulose, and lignin. So if we can successfully to separate the cellulose or hemicellulose, then we can basically convert many products from cellulose. So from cellulose, it goes to the glucose, and then we can convert basically almost everything. So fatty acid is just like, it's pretty much like petroleum oil. It just have a little bit extra of CO2. So if we can remove that CO2, then it's basically become just like hydrocarbon, and then you can have totally different industry in terms of oleochemicals and so on. And I think this will be the base of petrochemical industry in the future. This is the progress so far. So what we've done in university together with government and also a few private company, you can see in here, we have the green line in here. It means the one that already commercialized, like biodiesel and then bioethanol using fermentation. And then the one in yellow line here is basically on pilot plant scale. So we're trying to produce a different kind of fuel from palm oil directly. So I think this has been done also with Pertamina. And then the red color here is still under development. What we're really focusing right now is how to produce formic acid from, for example, from glycerol and also glucose, because we believe that formic acid is basically the best candidate as a hydrogen carrier for fuel cell. So that's what we're focusing on right now. And also we try to focus in terms of how to produce different kind of product from glucose, but the challenges is basically how to separate the lignocellulose and also how to produce a glucose with very cheap process, right? So that's basically the challenge. This is just an example of a sustainable route of formic acid. So what we're going to do, other than photo reduction, the one that being basically many researchers around the world doing a photo reduction, what we're going to do is basically try to convert glucose into a formic acid using enzymatic biomimicry catalyst. So that's basically what we're trying to do, how we can kind of copy the way enzyme works, but using the conventional catalyst, which is pretty cheap, right? This is just an ongoing research, several ongoing research. I'm going to show you here just a little bit. This is a synthesis of a biohexane and biohexene from sorbitol has been done. And then we also have few people working in different products, bio-based product like terpineol from turpentine using acid catalyst. So this can be used for disinfectant, cleanser, or perfume industry. We also produce biokerosene from coconut oil. This also has been done. And then in terms of biodiesel, we want to try to go a little further into producing high oxidation stability of biodiesel, because we want to move from 30% to 40% and so on. Because right now it's still not very good in terms of oxidation stability. So we have a problem in terms of storage, and then we have also a problem in the engine and so on. So if we can increase the quality of biodiesel, but at the same time also we can produce another product called DHA, which is quite expensive because it's been used in a cosmetic and food industry. So I think it's a win-win situation for everybody. So this is just also a few selected projects. We are trying to produce different kind of product like food coloring, food additive from natural resource like dragon fruit skin. We also try to produce supercapacitor, BioBTX, try to convert glycerin pitch, which is the side product of biodiesel industry, into value-added chemical. We also try to, of course, produce bioethanol, and also we try to working on the area of asphalt, rubber mix, and also essential oil. So I think that will be my last slide, and I leave it to you, this one. So the transition to bio-based economy is basically imminent, right? So and we cannot wait, so we have to do it together. So we're open for any collaboration from you guys who study there or become a lecturer or professor there. We welcome you to collaborate with us. Thank you so much. You can contact us in this email or website. And if you want to download this presentation, you can go to the website, which is using barcode on the right side over there. Okay. Thank you so much.
Thank you, Pak Akshay. It's definitely encouraging to see how academically we are leading in the sector of bioenergy. Although there are challenges, as mentioned, regarding to our tendency of short-sightedness and needing more investment, but still definitely intriguing to see how lignocellulosic and other material potentially unravel in the future. So a lot of exciting developments ahead. I'd like to bring up one more question due to the limited time. There are several questions about this. I guess because we discussed about bioenergy and green fuel as well towards our energy transition journey, there are questions regarding how do we achieve this target of new and renewable energy mix, as well as carbon emission reduction, while also avoiding the risk of deforestation and biodiversity loss due to palm oil plantation? Maybe this question can be answered by all of the panelists. Maybe Pak Aksha would like to answer first.
Okay, so in terms of this bioenergy target, right? So I think it's true in the near future. I think we're going to produce a lot of biofuel, biodiesel, for example, biogasoline, biojet fuel also as well. And then, of course, some bio-based chemical from palm oil based material, right? So do we have to worry about deforestation? I don't really think so, because I think if you follow the news and so on, right now we do have a few new varieties that basically can double the production of the palm oil that we have. So that's basically it's above of many kind of plant oil. For example, you can mention canola oil or rapeseed oil. So I think we don't have to worry about this deforestation. I don't think we really need a new plantation to open a new plantation. I think we can just replace the old one with the new variety, and we will double the production of palm oil, and at the same time also we double our production in terms of biofuel, even triple. I don't think we have to worry, because right now we still in 70% of them we export it outside, and we only using about 20 to 25% of the production of palm oil for the biofuel. So I don't think we need to worry. Thank you.
Thank you, Paksha. That is clear. Thank you, everyone, for coming to our session today. Before we close our session and today's event, we would like to give a massive thank you to all of our speakers and for the audiences for joining us in this two-day event. Thank you for being part of ISIC. And now we want to bring you back to the main Zoom window. We hope you enjoyed the session today, and we hope to see you again at the next Indonesia Scholar International Convention in 2022. Thank you.
Thank you so much.